something awfully screwy going on around here.
Hello everyone, and welcome to this month's exciting XMD Tip and Trick. First of all, I'd like to pay homage to Elmer J. Fudd. Last month at the end of the video I was sounding like him according to a couple of my colleagues, and they were right. I said I think we accomplished quite a bit around here, so I guess I've watched too much Looney Tunes when I was a kid. So anyway, let's move on to this month's tip and trick. So, quick review of what we did last month. We took a part and we started a job in XMD built mold base. We did a standard base here, DME mold base. We imported the insert. We cut the pockets through the core block. We screwed the insert to the support plate. We added water. We added ejection, and we did all that in about 7 minutes. And also, as I was saying, as we look at the 3D plates here, if I add an ejector pin, all of the holes are taken care of automatically. The clearance holes are put through the insert into the core block and into the retainer plate. So let's move on and look at the 2D stuff. I didn't show you this last month, but XMD has some really clean looking 2D drawings that are created automatically with the 3D. And they're live drawings. You can work in them and you can update the 3D as you move along here. So anything that I do in the 2D is will update the 3D, and the 3D updates the 2D. So what I'm going to do is add the counterbores for the water lines through the core block. And I'm going to do this in the 2D view because sometimes it's easier to pick lines in 2D space than it is to pick a spot in the depth in 3D space. So I'm going to just pick 2 lines here. And I'll make a quick switch over to the long section, as XMD's asked me where to place the hole. And I'm picking the center of the water line, specifying a diameter, and we'll put a chamfer on there and we'll put it in the core block. And there's the first one, just picking the center of the 2D circle, and there's the second one. So I'm going to do a switch back to the core plan, and XMD has this mirror copy the quadrants command. So all I'm going to do is just pick one of the counterbores, select it, hit enter, and you'll see the other 3 appear. And I'll do that for the second one as well. Equal and opposite quadrants. I'll hit enter, and my counterbores are complete. We'll quick switch over here to the 3D view, and you can see the counterbores are automatically added. Now I'm going to add what we call smart patterns, and these are a database of components. You get about 200 or 300 with XMD, and you can add your own, create your own custom assemblies. And I'm going to add a waterline extension, and we'll place that in the 3D view. Once this component is added, it's counted in the XMD database, automatically added to the material list. You can move them, you can copy them, and you can see we can edit them as well. There's the component. We're a little too long there, so I'll show you how we can edit these things. It's really quite easy. As soon as these smart patterns are added, they're saved in a folder with the job, so wherever the file goes, the smart patterns go with it. Okay, so we're getting shorten this. We'll shorten this guy up a little bit. So I've edited this, and now we've just went to the original drawing, and I'm going to use key creator command to box move. I'm going to box move that solid and shorten it up a little bit. And after making the modifications, you do a quick reformat. It's been updated. I'll switch back to the tool design, click the redraw component command, and you'll see that it will shorten up. Now I'm just going to copy the one component over to the other hole, And as I did previously with the counterboard holes, I'm just going to do mirror to different quadrants. Select the component, hit enter, and I'll select the second component, hit enter, and my connectors are added to the job. And here's the 2D updated automatically. Okay, now we've got some slides to deal with. So these slides were created in Key Creator or some other system for that matter and imported into the system. So XMD has an import plate command, and I'm just going to pick the component, pick the bottom, and now that's part of the XMD database. I can add water to those, I can add screws, I can add holes, I can add pockets, and it's all respected by XMD. And once again, these slides will be automatically added to the bill of materials, which we'll look at in another video. So now with the slides in place, we're going to put some pockets in the core block to seat the slides, of course. A lot of different options for pockets. We can add pockets, we can add plates, we can put rads on them, we can make square corners just by sketching. So I'm going to pick 2 points here, and I'm going to select position, and what I'm going to do is select the bottom of the wear plate, and I'll select out of view because I want that pocket to come out of the top of the core. Okay, there's one pocket created. Now I need to create a little bit of a wider pocket to house the slide gibs once they go in. The slide gibs are going to be about 1 inch wide and 6 inches long, so I will put a pocket in there to accommodate those. Here's where I can change the different rad situations, chamfer situations. Alright, another little sketch here. Alright, you can see the new pocket. We can modify the sizes of these pockets and locations at any time. Now I'm going to mirror them across to the other side. There's my second set of pockets. Quick look at the core block. I'm going to change the transparency of the block here. We'll add some dark lines just to improve the viewing here a little bit. So there you can see the pocket layout. And of course the core block layout. So that's manifold 3D solid ready for manufacture. Here's my build up. And that's it for this month. Thank you, folks.
That's all, folks.